So this is just a quick video on a mod that I've done to a couple of Uniden Washingtons. It's just having a frequency readout here where normally you'd have the AM upper and lower sideband LEDs. That is one of those little narrow OLEDs. I think it's 128 by 32 pixels and it fits in there really quite nicely. I had to cut a little bit of the plastic away from the front panel. After you pull this screen off, you can cut a little bit away so it drops in nicely. And I put an I2C driver to drive the LED, and it's the same I2C lines obviously that do the OLED, so that was really convenient. I'll show you how that works in a minute. This radio has been modified to do a few extra channels with a serial PLL that I put in there. It had originally a masked PLL in here. I can't remember what the number is. So I've just got a nano in there and a serial PLL in place of the PLL that was in there. So it's actually got all the original circuitry for the VCO and everything like that. So here's the channels. It's got, you know, all the extras. A little bit of fun there. Got the subs, and it's got dial acceleration as well, so if you turn it faster it'll shoot up and down a lot faster, but you can also like just get all the channels on the way through. And then I repurposed the channel 9 button to do the zeros, so when you press that in, the channel 9 light comes on just to show that you're on the zeros. So then it just basically drops 5kc because there's, you know, a lot of international skip that comes in, especially from Europe, I think, on the zeros. So yeah, it was a mod that I did because I really like the LED here, but when you've got extra channels it gets quite difficult to figure out what frequency you're on, so it needed a frequency readout. So that's where this is. It's not a counter, it's just a frequency readout that's controlled by the nano. All right, I'll show you what that board looks like. Okay, that's what it looks like on the inside. I kept the original PCB in here because it was good to actually mount everything in there nice and neatly. And these 4 wires here are all that you need. That's just the ground, the supply, and the I2C data and clock lines. That's all that you need to drive the LED and the OLED. I'll just pull that board out and show you what it looks like. Okay, this is what the module looks like. You can see that I've used the original PCB that came with the radio, and I've put a little blue screen in there instead of that red, the filter. This is the driver chip. You can see it's a HT16K33. You can get those that module, you can buy them manufactured already for about $3 or something like that, $4. They're a really good board, good value. They will drive up to 8 digits of 7-segment displays. It multiplexes them for you, so you just need to send the data in once via the I2C, and it will multiplex the digits for you. And you don't even need resistors on the LED lines, so it saves a lot of mucking around when you're trying to manufacture something like that. If you're building it, you can just put the pins of the LED block straight to the pins of the driver module, so that does make it easy. I had to put an RF choke on here. You can see in there the 3-volt line, the 3.3 volt line comes in here, but these OLEDs actually throw a lot of noise out if you try to run them on 5 volts. They work fine on 3.3, so I suggest if you're ever doing that, always use 3.3 volts. But the multiplexing on these LEDs actually did throw a whole lot more noise out down the supply line. So I had to put an RF choke in there, and I originally had a 100 mic cap, which I thought was plenty to decouple such a small module like that wasn't really doing much, but it actually still had a lot of noise on the supply line. at least on the board side of the choke. So when I put it to 1000 mic, that actually cleaned it all up. So if you're going to build one of these and you're going to decouple it with an RF choke, which you probably should do because it's a radio and you don't want to throw noise everywhere, then you're going to need a pretty hefty capacitor on there, probably because the switching current on these things is pretty sharp and it does throw a lot of noise. Anyway, that's that. This is the module that you can buy. Nice and small and easy and very cheap. And then you've probably seen these OLED. This is the one for the frequency display. Okay, so that's it. I just thought I'd show you that because I had the idea of putting that frequency readout. When I did this channel expansion, I wanted to keep the LEDs here, but I really wanted a channel readout somewhere on this radio, and so I realized that this slot here is a really good spot for it, and those little OLEDs fit in there really well. So I just thought, if maybe if I show this to some people, you might get the idea and do it yourself if you're offering DDS conversions for channels on these radios. You've seen how easy that board is to make. If you wanted to design a PCB, you could make it so that this would be even easier. I spent hours trying to get this to work, and to fit it all in there and everything like that. But now I know how to do it. If I had a PCB, or if you made a PCB, you could drop those components on there. It would cost you like literally, I don't know, $5 to make the whole thing. And then you've got just 4 wires coming off, and then that's all you need to plug in your I2C to your Nano or your control module. So it makes it really easy. Did a red one as well, and that turned out as good as well. So yeah, that's it. I like those LEDs. All right, see you later.